what if I told you that everything you know, every city, every nation, every dream humanity has ever dreamed, exists because of one single day, 66 million years ago, a day when the sky caught fire,
A day when the ground shook across an entire planet. A day when the rulers of Earth, creatures that had dominated for 160 million years, were erased in hours. This is not just the story of dinosaurs. This is the story of the worst day in Earth's history and how it made us possible. Stay with me, because by the end of this video, you will never look at the sky the same way again. We'll explain everything in this video, step by step. Don't skip it. There are days in history that divide time itself, days so immense that everything before them feels like a different universe. 66 million years ago, the Earth experienced such a day, long before there were nations, long before there were kings or revolutions or written words. There was a world ruled by giants. The age we now call the Late Cretaceous was warm, lush, and teeming with life. Vast forests stretched from pole to pole. Shallow seas cut across continents. Flowering plants bloomed for the first time in history, and across these landscapes walked creatures of unimaginable size and power. The dinosaurs were not monsters of myth. They were animals, living, breathing beings adapted perfectly to their world. In what is now North America, the mighty Tyrannosaurus rex stalked river valleys. Its footsteps shook the ground. Its eyes scanned for movement. Nearby, herds of horned triceratops grazed on low vegetation, their frills catching the sunlight. In the skies above, enormous Quetzalcoatlus soared on wings, wider than a small airplane. Life was not peaceful, but it was balanced. And then, in a single day, balance gave way to catastrophe. Far beyond Earth's atmosphere, a mountain-sized asteroid had been traveling silently through space for millions of years. Roughly 10 to 12 kilometers wide, it moved at more than 20 kilometers per second, faster than any bullet humanity would ever invent. It did not know it was headed for a world alive with forests and oceans. It did not know it was carrying extinction. On that morning, somewhere near what is now the Yucatan Peninsula, the sky would have seemed ordinary. The sun rose, the rivers flowed, dinosaurs fed their young, and then a new star appeared in the sky. It grew brighter by the second. When the asteroid struck, it struck with a force greater than billions of nuclear bombs. The impact site, known today as the Chicxulub crater, marks the scar of that moment. In less than a heartbeat, rock vaporized, oceans surged. The ground liquefied, temperatures near the impact reached thousands of degrees, hotter than the surface of the sun. Everything within hundreds of miles died instantly, but the true horror unfolded in the hours and days that followed. Debris blasted into the upper atmosphere and then rained back down across the globe as molten glass. Forests ignited. Wildfires raged on continents thousands of miles away. The sky darkened as soot and dust choked the sunlight. For months, perhaps years, the Earth entered a winter without snow. Photosynthesis collapsed. Plants withered, herbivores starved. Carnivores followed. The reign of the dinosaurs, which had lasted more than 160 million years, far longer than humanity has existed, ended not with a gradual fading, but with a violent punctuation mark. And yet, even in catastrophe, life endured. Small mammals, creatures no larger than squirrels, survived in burrows and hidden shelters. Birds, the feathered descendants of dinosaurs, persisted. Seeds lay dormant in the soil, waiting for light to return. The extinction that erased nearly 75% of Earth's species cleared ecological space for something new. In the shadow of destruction, opportunity emerged. The age of mammals began quietly. No trumpet announced it. No grand procession marked its rise. But over tens of millions of years, these small survivors diversified. They climbed trees. They returned to the seas. They returned to the seas. They learned to run across open plains. Eventually, one lineage would stand upright, fashion tools, and look back into the abyss of time with wonder. We are here because of that day. It is a sobering truth. Human civilization, every poem ever written, every city ever built, every hope and heartbreak and revolution, rests upon the ashes of a vanished world. The last day of the dinosaurs, the last day of the dinosaurs, was not merely an ending. It was a hinge in the history of life. It reminds us that dominance is temporary, that even the mightiest can fall, that the Earth does not bend to power or size or strength. For 160 million years, the dinosaurs ruled with quiet supremacy. They survived volcanic eruptions, shifting continents, rising seas, They adapted and thrived across a changing planet, and yet in a matter of hours, a force from beyond the sky rewrote the story. There is humility in that. The Earth is resilient, but it is not invulnerable. Its history is not a straight line of progress, but a series of fragile moments. Balance is maintained, then broken. When we study the extinction of the dinosaurs, we are not merely looking backward. We are confronting a truth about our own existence, that life is precious because it is precarious. 66 million years ago, the world burned. The skies darkened. The giants fell. And in the quiet that followed, and forests stripped bare and oceans turned cold, the seeds of our own story began to grow. The last day of the dinosaurs was the end of one age. It was also the first page of ours. 66 million years ago, the Earth stood at the height of a long and astonishing reign. The late Cretaceous world was not a dying world, not a fading empire gasping for breath, but a planet in full bloom. It was warm, restless, alive with color and movement. Continents sat in unfamiliar positions, separated by shallow inland seas that shimmered beneath a brighter sun. There were no polar ice caps. Forests reached toward high latitudes. Sea levels were hundreds of feet higher than today, swallowing coastlines we now know and creating new horizons teeming with life. Across this ancient landscape walked the giants. In the floodplains of what is now western North America, the immense Tyrannosaurus rex, Prehistoric Tyrannosaurus rex, moved with calculated purpose. We often imagine it as a roaring terror, but it was first and foremost an animal finely tuned by evolution. Its forward-facing eyes judged distance with precision. Its powerful legs carried nearly 7 tons of muscle and bone. It could sense vibrations through the ground, perhaps detecting prey long before it was visible. This was not chaos, this was ecological order. Predator and prey locked in an ancient dance that had unfolded for millions of years. Nearby herds of asterisk triceratops grazed in cautious groups, gazed in cautious groups. Their 3 horns were not decorative flourishes, but instruments of survival. Their great bony frills, laced with blood vessels, may have flushed with color in mating displays or warnings to rivals. When threatened, they did not scatter blindly. Fossil evidence suggests they moved in herds, a collective shield against attack. Calves stayed close to adults, protected within the circle of horns and muscle. In their presence, we glimpsed something deeply familiar: community instinct, the quiet urgency of survival. The land itself was changing, flowering. Plants, still relatively new in evolutionary terms, were spreading rapidly. Angiosperms painted the landscape with blossoms. Insects buzzed between them, pollinating in intricate partnerships. The world was not monochrome. It was alive with texture and scent. Ferns unfurled along riverbanks. Towering conifers rose above mixed woodlands. Fallen leaves fed soil rich with microorganisms. Life fed life in a seamless web. Along coastal plains and in marshy lowlands, duck-billed dinosaurs like Edmontosaurus traveled in vast migratory groups. Their beaks clipped vegetation efficiently, while rows of grinding teeth processed tough plant fibers. They were numerous, so numerous that they formed the backbone of entire ecosystems. Their movements carved trails across the earth. Their waste nourished the soil. Their very presence shaped the environment, much as large herbivores do today. Above them, the skies were no less dramatic. Enormous pterosaurs, such as Quetzalcoatlus, soared on thermals, wings stretching wider than a small aircraft. From the ground, their shadows must have been awe-inspiring. These were not clumsy gliders, but capable flyers, able to cross vast distances in search of food. They nested, they hunted, they endured storms and shifting winds. The sky, like the land, belonged to giants. Beneath the oceans, another kingdom thrived. Vast marine reptiles cruised through warm seas that covered much of the continents. Among them was Mosasaurus, a sleek and formidable predator. Its body undulated through the water with power and grace. Coral reefs flourished in the shallows, nurseries for fish and invertebrates. Ammonites drifted in elegant spirals, their coiled shells catching filtered sunlight. Plankton bloomed near the surface, forming the invisible foundation of marine food chains. The seas were vibrant, layered, and astonishingly productive. And yet, for all its grandeur, this was not a static world. Continents were drifting apart under the slow force of plate tectonics. Volcanoes smoldered in what is now India, laying down massive lava flows known today as the Deccan Traps. Mountains rose and eroded. Rivers carved new paths. The late Cretaceous was a world in motion, dynamic and responsive to internal forces. The dinosaurs were not relics clinging to stability. They were adaptable, diversified, occupying nearly every terrestrial niche imaginable. Feathers adorned many species. Feathers adorned many species. Some theropods bore plumage that shimmered in the light, suggesting displays of courtship and communication. The line between dinosaur and bird had already blurred. In trees and along shorelines, early birds flitted and called. Eggs were tended in nests. Parents guarded their broods. The fossil record shows evidence of care, of growth rings and bones, indicating seasonal cycles of lives structured by rhythms of abundance and scarcity. Small mammals scurried in undergrowth and burrows, living mostly in the shadows of reptilian dominance. They were not yet rulers of the earth, but they were present, adaptable, nocturnal, cautious. They fed on insects, seeds, and small prey, surviving through agility rather than size. Their hearts beat quickly in fragile bodies, unnoticed by the giants overhead. The climate itself shaped this tapestry of life. Greenhouse conditions meant warmer average temperatures. Rainfall patterns supported dense vegetation across much of the globe. There were storms, immense and powerful. But there was also consistency. The poles, though dark for months each year, remained forested rather than frozen. Dinosaurs adapted, even to these extremes, enduring seasonal light shifts in ways we are only beginning to understand. If one had stood on a rise overlooking a late Cretaceous plain, the scene would not have seemed apocalyptic or precarious. It would have felt abundant. The air thick with the hum of insects. The ground trembling faintly with distant footsteps. Calls and cries echoing across wetlands. Predators watching from cover. Herbivores cropping ferns in rhythmic motion. A living system refined over tens of millions of years. There is a temptation to imagine this age as primitive, as somehow incomplete because it preceded us. But in truth, it was a culmination. The dinosaurs had survived previous mass extinctions. They had diversified after catastrophe. They had grown into forms both colossal and delicate. Their bones show evidence of injury healed, of battles fought and survived, of long lifespans carried to maturity. This was not a world waiting to end. It was a world confident in its continuity. Each sunrise brought warmth across fern-covered valleys. Each migration followed ancient roots embedded in instinct. Eggs cracked open under careful watch. Teeth were replaced as they wore down. Claws left impressions in soft mud that would, by chance and preservation, carry their story forward through deep time. For more than 160 million years, dinosaurs had endured. They were not an evolutionary experiment in decline, but a testament to resilience and adaptation. Their dominance was not fragile in any obvious way. Ecosystems were stable. Food chains were robust. The giants walked without knowledge of an approaching skyborne force. The seas shimmered without warning. Forest rustled in ordinary winds. It was a world whole unto itself, complete in its complexity, magnificent in its scale, unaware that its final sunrise under dinosaur rule was drawing near. Far beyond the warmth of the late Cretaceous sun, beyond the drifting continents and shallow inland seas, beyond even the outermost whispers of Earth's atmosphere, a silent traveler moved through the dark. It had no awareness, no end, inch and no malice. It was a remnant from the birth of the solar system, a fragment left over from the violent construction of planets more than 4 billion years earlier. For millions of years it wandered, circling the sun in a slow and indifferent orbit, crossing paths with nothing but vacuum and starlight. Then gravity intervened, a subtle shift. Perhaps the tug of Jupiter, perhaps a collision in the asteroid belt, nudged it from its ancient path. What had been a stable orbit became an elongated plunge inward. The object, roughly 10 to 12 kilometers wide, now hurtled toward the inner solar system. It traveled at speeds exceeding 20 kilometers per second. Faster than any storm, faster than any creature that had ever lived. In the vast silence of space, it accelerated, without friction, without sound. On Earth, there was no warning. No creature lifted its head in suspicion. No tremor rippled through the soil. The forests of the late Cretaceous continued their cycles of growth and decay. Rivers wound through floodplains. Predators stalked prey. The sky appeared as it always had, blue by day, scattered with stars by night. And then, in the final hours of its journey, the asteroid entered Earth's gravitational embrace. Drawn downward with irresistible force, it fell toward a planet alive with color and movement. As it approached, Earth grew larger in its view, oceans glinting in sunlight, clouds swirling in pale spirals, continents shaped by eons of tectonic motion. The asteroid's surface, cold and ancient, bore scars from earlier collisions. It carried within it metals and minerals forged in primordial violence. It was a time capsule from the dawn of the solar system, now transformed into an agent of destruction. When it struck the upper atmosphere, the encounter ignited the sky. Friction with air superheated its surface. A blazing fireball formed around it, bright than the sun. For creatures below, it would have appeared as a new star descending rapidly, growing larger with impossible speed. In those final seconds, the object did not slow meaningfully. The atmosphere, thick as it is to us, was to this mass little more than mist. The impact occurred in what is now the Yucatan Peninsula of Mexico. The scar it left behind is known today as the Chicxulub crater, Chicxulub crater, buried beneath limestone and coastal waters. At the moment of collision, the energy released equaled billions of atomic bombs detonating at once. Rock at the point of contact vaporized instantly. The asteroid itself was obliterated, transformed into plasma and debris. The ground behaved not as solid Earth, but as liquid under the force of that blow. A cavity nearly 100 kilometers wide opened in seconds. Shockwaves rippled outward faster than sound, shattering rock, flattening forests, igniting everything combustible within hundreds of miles. The temperature near the impact site soared to thousands of degrees Celsius, hot enough to melt stone. An immense plume of vaporized rock and ejecta blasted high above the atmosphere, arcing into space before gravity pulled it back. Molten droplets of glass, tektites, formed as material cooled midair. These would rain down across continents, embedding themselves in sediment that would one day reveal the story. The oceans responded with fury. The asteroid struck a shallow sea rich in sulfur-bearing rocks. Water was displaced in colossal waves, tsunamis racing outward in all directions. Walls of water hundreds of feet high surged across coastlines, tearing apart ecosystems in moments. Marine life near the impact site perished instantly, crushed or boiled. But the devastation did not end with the initial blast. Dust and soot filled the atmosphere. Sulfur aerosols spread globally, reflecting sunlight back into space. The sky darkened, not just locally, but worldwide. In a matter of days, temperatures began to drop. Photosynthesis faltered as light diminished. Plants that had flourished in warmth and abundance began to wither. Wildfires ignited on a continental scale. The returning ejector re-entered the atmosphere at high speed, generating intense heat pulses. Forests thousands of miles from the impact erupted into flame. Charcoal layers preserved in rock testify to the breadth of these fires. Smoke joined dust in choking the sky. The impact marked the boundary between geological ages, what scientists call the Cretaceous Paleogene extinction event. In sediment layers around the world, a thin band rich in iridium, a rare element more common in asteroids than in Earth's crust, signals the moment of change. It is a chemical fingerprint of catastrophe, found from North America to Europe to Asia. The asteroid did not discriminate. It did not choose its victims. It reshaped climate systems, disrupted food chains, altered ocean chemistry. In the seas, microscopic plankton that formed the base of marine ecosystems began to die off. On land, herbivorous dinosaurs faced dwindling vegetation. Carnivores soon followed. The force that ended the age of dinosaurs was not gradual evolution or competitive displacement. It was cosmic chance. A wandering fragment of primordial rock intersected with a living world at precisely the wrong moment. The stability of 160 million years unraveled in hours. And yet within the violence lay complexity. The angle of impact, likely oblique, amplified devastation in certain directions. The composition of the Yucatan's crust, rich in volatile compounds, intensified atmospheric effects. Had the asteroid struck deeper ocean or solid granite elsewhere, the aftermath might have differed. History hinged on geography as much as on mass and speed. For a brief instant, Earth's surface glowed with heat. Shockwaves circled the globe. Seismic energy equivalent to the strongest earthquakes ever recorded rippled through tectonic plates. Even on the far side of the planet, the ground would have trembled. Creatures that looked to the sky that day saw something no life form had ever witnessed. A sun within the sun descending with unstoppable force. In less time than it takes for a heart to beat, the reign of giants was confronted by a power beyond biology, beyond adaptation. The asteroid's journey had begun in the chaotic infancy of the solar system. It ended in a collision that reshaped the trajectory of life on Earth. Its fragments, scattered and buried, remain beneath the Yucatan's soil. The crater itself, hidden for millions of years, would not be confirmed until the late 20th century, when geophysicists traced gravitational anomalies beneath the surface. The heavens, once regarded as fixed and eternal, revealed themselves capable of intervention. The boundary between Earth and space proved permeable. Life's history, it turned out, was not written solely by what evolved within oceans and forests, but also by what arrived unbidden from the depths of the cosmos. The asteroid from the heavens carried no banner, no omen understood by those below. It arrived in silence and departed in fire, leaving behind a planet forever changed, its atmosphere thick with ash, its ecosystems trembling under the weight of sudden darkness in the immediate aftermath of the impact at the asteroid Chicxulub crater. The world did not simply fall silent. It screamed. The shockwave moved faster than sound itself, flattening forests and stripping vegetation from the earth. Within minutes, seismic tremors equivalent to earthquakes far beyond anything in recorded human history rippled across continents. Ground that had held firm for millions of years heaved and fractured. Rivers reversed course. Cliffs collapsed. Creatures that had survived the initial flash of heat now faced a landscape convulsing beneath them. Material blasted into the upper atmosphere began its return to Earth. As ejecta re-entered at extraordinary speeds, it superheated the air. For a terrible span of hours, the sky glowed red. Temperatures spiked across vast regions, igniting forests far from the impact site. These were not isolated blazes sparked by lightning, they were continental firestorms. Leaves curled and blackened. Resin-rich trees exploded into flame. Smoke climbed in thick columns, merging into a global pall. Animals ran, but there was nowhere to run. Herds that had grazed peacefully that morning were engulfed by advancing walls of heat. Rans and jousts by castrack. Predators and prey alike succumbed to suffocation or burning. In coastal regions, tsunamis driven by the impact roared inland, tearing apart ecosystems already ablaze. Water and fire converged in a grotesque symmetry of destruction, yet the inferno, as catastrophic as it was, marked only the beginning of a longer ordeal. Dust, soot, and pulverized rock filled the stratosphere. Sulfur vaporized from the limestone-rich crust of the Yucatan, mingled with the debris, forming aerosols that spread around the globe. The sky darkened not gradually, but with startling speed. Sunlight that had once bathed tropical forests and polar woodlands alike became filtered and dim. Within days, daytime resembled twilight. Photosynthesis faltered. Plants that formed the foundation of terrestrial food webs relied on sunlight to convert energy. Without it, their growth slowed, then ceased. Leaves fell prematurely. Flowers failed to bloom. Crops of ferns and shrubs withered. The lush landscapes of the late Cretaceous began to lose their vibrancy. What had been green and thriving turned brittle and brown. As vegetation declined, herbivorous dinosaurs faced starvation. Species such as Asteroid Triceratops and Asteroid Dinosaurs, once sustained by abundant plant life, found their food sources dwindling. Their massive bodies required enormous quantities of nourishment. Instinct drove them to migrate, to search for sustenance. But the darkness was global. The collapse was systemic. Carnivores, including apex predators like Tyrannosaurus rex, initially may have scavenged from the chaos. The aftermath of fires and tsunamis provided carcasses in abundance, but this grim harvest was temporary. As herbivores perished in growing numbers, so too did the predators that depended on them. The intricate web of life began to unravel, strand by strand. In the oceans, a parallel tragedy unfolded. Microscopic plankton, tiny organisms invisible to the naked eye, formed the base of marine food chains. They too depended on sunlight. As the sky dimmed, plankton populations crashed. Coral reefs bleached and died. Ammonites that had drifted in graceful spirals through warm seas vanished from the fossil record. Marine reptiles such as Mosasaurus found their prey disappearing. Entire oceanic ecosystems faltered. The darkness was accompanied by cold. With sunlight blocked by atmospheric debris, global temperatures plummeted. This was not a gentle cooling, but an abrupt climatic shock. Regions that had enjoyed greenhouse warmth experienced freezing conditions. Frost may have touched areas that had never known ice. The Earth entered what scientists call an impact winter, a period of prolonged chill and diminished light. Rain fell, but it was not life-giving rain. Sulfur aerosols in the atmosphere combined with water vapor to produce acid rain. This corrosive precipitation altered soil chemistry, damaged plant tissues, and leached nutrients from ecosystems already under stress. Freshwater systems became inhospitable to many species. Lakes and rivers turned toxic for organisms unadapted to such rapid change. The rhythm of seasons, once predictable, dissolved into instability. For months, perhaps years, the sky remained obscured. Day merged with dusk. The vibrant calls of birds and reptiles gave way to eerie quiet. Fossil evidence suggests a fern spike in the geological record, a sudden proliferation of hardy ferns that often colonized devastated landscapes. In the wake of fire and ash, these resilient plants took root where forests had burned, signaling both destruction and the earliest stirrings of recovery. Small animals with modest energy requirements stood a better chance of survival. Mammals no larger than modern rodents sheltered in burrows, feeding on seeds and detritus. Their size became an advantage. They required less food, less territory. They could hide from temperature extremes underground. Likewise, some bird lineages, descendants of feathered dinosaurs, persisted, their ability to fly offering mobility in a shattered world. But for the great non-avian dinosaurs, the collapse was relentless. Eggs laid in nests went untended as adults perished. Juveniles lacked the resources to reach maturity. Even species that might have survived the initial weeks faced a prolonged scarcity with no reprieve. Evolution had prepared them for competition, for predation, for gradual environmental shifts. No, it had not prepared them for a sunless sky. The geological boundary marking this extinction, known as the Cretaceous-Paleogene boundary, preserves evidence of these cascading effects. Layers of soot, shocked quartz, and iridium trace the sequence of fire, impact, and atmospheric upheaval. It is a thin line in stone, representing a profound rupture in life's continuity. And yet, amid devastation, Earth's systems slowly began to recalibrate. Dust eventually settled. Aerosols dissipated. Sunlight filtered back through thinning clouds. Temperatures stabilized, though not to their former warmth. New ecological niches emerged in the absence of the giants. Forests regrew in altered forms. Mammals diversified cautiously into spaces once dominated by reptiles. The world that emerged from the darkness was not the world that had been binged. It was quieter, emptier. The thunderous footsteps that had defined the Mesozoic fell silent. No herds of massive herbivores trampled fern-covered plains. No towering predators stalked riverbanks with bone-crushing jaws. Entire branches of evolutionary history had been severed. The firestorms subsided. The ash settled into soil. The acid rain ceased. But the balance that had governed life for over 160 million years was gone. In its place stood a fragile new order, shaped by survival rather than supremacy, by resilience rather than dominance, by creatures small enough and adaptable enough to endure a world plunged into flame and shadow, a world that had burned under falling stars and then shivered beneath a sunless sky. The extinction was not a single moment, but a widening silence. In the geological record, it appears as a thin boundary line, an almost invisible seam between worlds. Scientists call it the Cretaceous-Paleogene extinction event, often shortened to the KT boundary. Above that line lies a new chapter of life. Below it rests a world that endured for more than 160 million years. Between them sits a layer enriched with iridium, shocked quartz, and microscopic spherules. Evidence of catastrophe written in stone. Yet the true meaning of that boundary is not measured in minerals. It is measured in absence. Approximately 75% of all species on Earth vanished. Entire ecosystems collapsed. On land, the great non-avian dinosaurs disappeared completely. Creatures that had dominated continents adapted to. Deserts and forests and polar woodlands left no living descendants except for the lineage that had already taken wing as birds. The mighty Asteroid Tyrannosaurus rex, apex predator of its age, ceased to exist. The horned Asteroid Triceratops, armored and formidable, vanished from the earth. The duck-billed Asteroid Edmontosaurus, once abundant in vast herds, left behind only fossilized bones. In the oceans, loss was equally profound. The elegant ammonites, which had survived multiple previous extinction events, finally succumbed. Great marine reptiles such as Asteroid disappeared. Plankton communities were decimated, disrupting the foundation of marine food webs. Coral reefs, complex structures built over thousands of years, collapsed under the weight of chemical and thermal upheaval. This was not selective pruning of thermal upheaval. This was not selective pruning. It was systemic failure. The KPG extinction was one of 5 major mass extinctions in Earth's history, but it was unique in its swiftness and its cause. Unlike the gradual climatic shifts or volcanic episodes that defined earlier die-offs, this event was triggered by a sudden extraterrestrial impact at the site now known as the asteristic Chicxulub crater asteroid. The violence of that collision cascaded through atmosphere, ocean, and land in ways that magnified its reach. Species that depended on stable, energy-rich ecosystems were hit hardest. Large-bodied animals with high metabolic demands found themselves without sufficient food. Specialized organisms, those finely tuned to narrow ecological niches, had little room to adapt. The collapse of plant life meant herbivores starved. The starvation of herbivores meant carnivores soon followed. In the oceans, diminished sunlight meant reduced photosynthesis among plankton, leading to starvation up the food chain. The fossil record reveals a sharp discontinuity. Dinosaur bones are found abundantly below the boundary layer. Above it, they are gone. In their place appear smaller mammals and surviving bird lineages. The absence is striking not only for its scale, but for its abruptness. It is tempting to imagine the extinction as a dramatic crescendo, a final battle between species and environment. But in truth, it was quieter. It unfolded over months and years of dwindling resources, failed reproduction, and ecological unraveling. Nests went untended. Eggs failed to hatch. Juveniles could not reach maturity. Populations shrank until they reached a point from which recovery was impossible. The extinction did not strike evenly across all groups. Crocodilians survived, perhaps due to their ability to endure long periods without food and to inhabit freshwater systems less immediately affected than open oceans. Turtles persisted. Small mammals capable of burrowing and consuming varied diets weathered the collapse. Birds, particularly those that fed on seeds, managed to endure the prolonged darkness. Size, adaptability, and dietary flexibility became decisive factors. The very traits that had once seemed modest, small stature, nocturnal habits, generalist feeding, became keys to survival. Meanwhile, the grandeur of the giants offered no protection against planetary upheaval. In the marine realm, recovery was slow and uneven. Reef systems took millions of years to rebuild. New forms of plankton gradually repopulated the seas. Fish lineages diversified in the absence of dominant marine reptiles. On land, forests regrew in altered compositions. Ferns and hardy shrubs colonized burned terrain before trees reestablished themselves. The extinction reshaped not only which species survived, but how ecosystems functioned. The removal of dominant herbivores altered vegetation patterns. The disappearance of apex predators allowed new food webs to form. Evolutionary pathways once constrained by dinosaur dominance opened to other lineages. For more than 160 million years, dinosaurs had defined terrestrial life. Their extinction marked the end of the Mesozoic era and the beginning of the Cenozoic era and the beginning of the Cenozoic, the age of mammals. Yet that transition was not immediate triumph, but gradual emergence. Mammals did not inherit a thriving world. They inherited a scarred one. The KPG event serves as a reminder that dominance is not permanence. Evolution produces resilience, but not invulnerability. Entire branches of life can flourish for millions of years and still be erased by forces beyond biological control. The dinosaurs had survived previous environmental shifts, volcanic episodes, and continental rearrangements. What they could not survive was the compound shock of impact, fire, darkness, and climatic collapse. In sedimentary rock around the world, the boundary remains visible, a narrow band of clay enriched with extraterrestrial elements. It is astonishingly thin, often only a few centimeters thick, yet it represents the loss of countless generations. Beneath it lie the bones of creatures that once thundered across plains. Above it lie the beginnings of a new order. Mass extinction is not merely loss. It is transformation through subtraction. It narrows possibility even as it creates space. In the wake of the KPG event, ecological niches stood empty. Mammals diversified cautiously into those spaces, evolving larger bodies and more complex behaviors. Birds radiated into new forms. Flowering plants adapted to different pollinators. The biosphere reorganized itself around survivors, but the magnitude of the loss remains staggering. 3 out of every 4 species vanished. The intricate web of late Cretaceous life was torn apart. What had been familiar rhythms of migration, predation, and reproduction ceased. Landscapes that once echoed with the calls of massive reptiles fell quiet. The extinction was not an ending scripted by destiny. It was contingency. An intersection of cosmic accident and biological vulnerability. The asteroid did not target dinosaurs specifically. It struck a world structured around them. The resulting cascade made their survival untenable. In the silence that followed, Earth bore witness to a profound resetting of life's trajectory. The giants were gone, the seas were altered, forests regrew without their towering inhabitants. The planet endured reshaped by catastrophe. The planet endured reshaped by catastrophe. Its future redirected by a thin layer of clay that marks the moment when the age of reptiles gave way to something smaller, quieter, and waiting in the shadows for its turn to rise, when the darkness began to lift and sunlight once again filtered through thinning skies. When the darkness began to lift and sunlight once again filtered through thinning skies. The earth that emerged was quieter, emptier, and filled with possibility. The giants were gone. The thunder of massive feet no longer shook the floodplains. The towering silhouettes that had defined horizons for more than 160 million years had vanished. In their absence, space, ecological, evolutionary, and literal, opened. It did not happen overnight. Recovery from the Cretaceous Paleogene extinction was slow and uneven. Forests had to regrow from scorched soil. Oceans had to regrow from scorched soil. Oceans had to rebuild their microscopic foundations. Food chains had to reassemble link by fragile link. The planet was healing, but healing in geological time is measured not in years, but in millions of them. In this altered world, mammals began to stir. They had lived in the margins during the age of dinosaurs. Small, mostly nocturnal creatures navigating underbrush and burrows. Their survival during the catastrophe was owed in part to their size and adaptability. Many could consume seeds, insects, or carrion. Some sheltered underground from firestorms and freezing temperatures. When the extinction cleared away dominant reptilian megafauna, mammals found themselves in a world no longer defined by towering competitors. The early Paleogene landscape was one of experimentation. Mammals diversified rapidly, a process scientists called adaptive radiation. Freed from ecological constraints, they evolved into forms that had once been monopolized by dinosaurs. Some grew larger, testing the boundaries of body size. Others specialized in climbing, digging, swimming. Within a few million years, mammalian lineages had begun to fill herbivore, carnivore, and omnivore roles across continents. Among the early groups were archaic hoofed mammals, insectivores, and primate-like creatures. The absence of predators like Asteroid Tyrannosaurus rex, Tyrannosaurus rex, meant that mammalian carnivores could evolve into apex roles. Over time, these would give rise to formidable hunters, ancestors of wolves, big cats, and bears. The evolutionary tree branched with remarkable speed compared to the long dominance of the dinosaurs. Birds, the surviving avian dinosaurs, also flourished. With non-avian dinosaurs extinct, avian species diversified into niches previously inaccessible. Some became large and flightless, reclaiming terrestrial roles. Others refined flight into new ecological strategies. The skies, once shared with giant parasaurs, now belonged entirely to birds. Vegetation, too, transformed. Flowering plants continued their ascent, reshaping landscapes and forming complex relationships with pollinating insects and seed-dispersing animals. Forests thickened in some regions. Grasslands began to emerge in others. Climate patterns shifted gradually toward cooler global averages compared to the greenhouse warmth of the Cretaceous. Continents continued their slow drift, sculpting new mountain ranges and altering ocean currents. As mammals grew in size and number, certain lineages took to the trees, from small, grasping hands and forward-facing. Eyes emerged early primates, adaptations suited to navigating branches and judging distance. These traits, modest at first, would prove pivotal. The primate lineage emphasized vision over smell, dexterity over brute strength, social interaction over solitary survival. Millions of years passed. Ice ages came and went. Tectonic plates collided, raising the Himalayas. Grasslands expanded, favoring grazing mammals with high-crowned teeth. Among primates, one branch began to experiment with upright posture. In Africa, several million years ago, early hominins walked on two legs across savannas, once patrolled by very different giants. The rise of humanity was neither inevitable nor immediate. It was contingent upon countless variables set in motion by that extinction event 66 million years earlier. Without the disappearance of large non-avian dinosaurs, mammals might have remained small, confined to nocturnal niches. Without the ecological vacuum created by catastrophe, primates might never have diversified in ways that allowed intelligence to flourish. Eventually, a species emerged capable of reflection. Asteroid Homo sapiens developed language, symbolic thought, and tools that reshaped environments at astonishing speed. Fire, once a force of planetary devastation, became an instrument of survival. Stone became spear and plow. Communities formed, then civilizations. Agriculture replaced foraging. Cities rose where forests once stood. Humanity's ascent was built upon deep time. The fossil fuels powering modern industry are remnants of ancient ecosystems. The limestone in buildings traces back to marine organisms that thrived long before the extinction. Even the birds that scatter at our approach carry within them the legacy of dinosaur ancestry. The age of mammals is often described as triumphant, but it was born from loss. The extinction that cleared the way for mammalian expansion was catastrophic beyond comprehension. The rise of one lineage required the fall of another. Evolution does not operate with sentiment, it operates with opportunity. As mammals diversified, so too did their complexity. Social structures deepened. Parental care extended, brains enlarged relative to body size. In primates, cooperative behavior and communication became survival advantages. Over time, these traits laid the groundwork for culture. Human beings would one day uncover the fossilized bones of dinosaurs and marvel at their scale. We would map the buried rim of the asterisk Chicxulub crater, confirming the cosmic blow that reshaped life. We would piece together sediment layers marking the KPG boundary and recognize how thin the line between eras can be. The rise of mammals was not merely a biological shift. It was a transformation in how life interacted with the planet. Large mammals influenced vegetation through grazing. Predators regulated herbivore populations. Marine mammals returned to oceans once ruled by reptiles. Ecosystems reorganized around warm-blooded metabolisms in fur-covered bodies. And eventually, one mammal began altering the planet at a pace rivaling geological forces. Humans cleared forests, redirected rivers, and emitted carbon stored for millions of years. The descendants of small, burrowing survivors became architects of global change. The story that began with falling fire and global winter culminated in consciousness, life capable of studying its own origins. The last day of the dinosaurs set in motion a chain of events that would lead to telescopes, scanning distant galaxies, laboratories, analyzing ancient DNA, and minds contemplating extinction itself. From scorched earth and shadowed skies rose creatures once confined to the margins. From burrows emerged builders of cities. From survival instincts evolved philosophy, art, and science. The age that followed catastrophe became an age defined not by scale of body, but by scale of thought, an era in which intelligence replaced enormity as the dominant force, shaping the fate of life on Earth. Thanks for watching this video, and don't forget to like and subscribe.